in rectangular form, I can convert it to polar form or trigonometric form. So let's go to number 10. Number 10, and this is, we are doing powers. So let's work on powers. And after we work on powers for some time, we get into the Moivre's theorem. So the Moivre's theorem worked on powers of complex numbers. All right, so the first thing I have to do is number 10. I can do it by ordinary foiling. So in number 10, I have 2 minus 2i squared. And I cannot rewrite, I can just rewrite it as 2 minus 2i multiplied 2 minus 2i. All right. Now that I have done it this way, I can FOIL. So foiling it, I have this multiply this and this multiply that, and I get an answer. So 2 times 2 is 4. 2 times negative 2i is negative 4i. Negative 2i multiply 2 is negative 4i again. Negative 2i multiply negative 2i is positive 2i squared. Remember in your junior class, Math 110, we talked, I don't know if your class, but I remember we talked about I squared is equal to negative 1 always. I to the power of 4 is equal to 1. So when you get the powers of I, you should be able to, okay, let's talk about, quickly talk about, not to, I won't take too much time because we have some things more important to do. Suppose I have evaluate I to power 9. Right now, I already know that I to power 4 is 1. So I can say I to power 4 multiplied by I to power 4 multiplied by I to power 1. And since this is 1, I won't worry about that. This is 1. And this is I. So my final answer is I. This is just a quick review. Well, suppose I am told to evaluate I to power 99. Well, let me just get a number that is. Everybody knows that. Let me say I to power 86. Okay, this is good. I to power 86. So I will start finding. But I already know that if I divide 86 by 4, I have 2 go here. So I have I to power 4. I to power 4. How many times? If I divide by 4, I have 2 here. If I divide, so I have 21. Then multiply by I to power 2. 21 times 4 is 84. Then plus 2. I to power 2, I already know it is negative 1. Any powers of I to 4 is 1, so I won't worry about that. Therefore, I to power 86 is the same thing as negative 1. That is, by the way, I just reviewed powers of I. That way you can, I hope you remember that. All right. So let's go back to what we were trying to simplify before. So now we go back to number 10. Is it number 10? The number we're talking about. Let's go there. Okay, so collect like terms together. Everybody remember that we multiplied 2 multiply negative 2i multiply negative 2i. We have positive. And then we have I squared. So because we know that I squared is negative 1, I want to rewrite. So if I rewrite this, I have negative here. Let me just put negative here. Okay, so, and then I want to write negative 2. Okay, so that's negative 2 finally. Collect like terms together. 4 minus 2 is 2 minus 8i in standard form. So I have written this number in standard form by foiling. But guess what? You will not be able to foil all the time. You won't be able to foil all the time. Okay, so we want to redo number 10 using multiplication formula. So we are going to powers of I. The Moivre theorem discovered how to evaluate powers of I. So we are going to talk about it now. If a complex number in polar form or trigonometric form, suppose I have Z1, and Z1 is 5, 6, 30 degrees, and I have Z2 is equal to 4, 6, 45 degrees. If I'm told to multiply Z1 by Z2, talking about Z1 multiplies Z2, so Z1 multiplies Z2 will be, first of all, what you are going to do is, if you have this, you got to add them up. So first of, in this one, let me make sure that we have, so we are multiplying. So I have 5 multiply 4 into, I'm going to expand. This is cosine of the first angle plus the second angle. In other words, you add inside. You have to obey all the signs of the unit circle. I sine angle 1, theta 1 plus theta 2. So you rewrite 5 times 4 is 20. So the modulus of Z1 multiply modulus of Z2, and then cosine of Z1, angle Z1 plus angle Z2. Remember, you're multiplying. So modulus multiply modulus whenever you're multiplying. Angle plus angle. All right. So I have 70 degrees here plus I sine 70 degrees. Okay. All right. So let's go to one that is longer. Maybe can we start from number 9? Let me see if another one is shorter. Start from number 9. Find the cube root. Now we have to raise the number to the given power and write the answer in rectangular form. No, we have already done something like number 4. Okay, well, we need to do something like number, all right, number 1 is good. Let's go to number 1. Everybody, I just explained number 1, by the way. So as we do this, we are actually applying powers. But the Moivre theorem says if I have n, okay, that's one called n1. That's n1. Suppose this is n is equal to whatever the number is. If this is n, you can now say that n squared, you multiply that n squared into cosine of n times the angle in the middle. Okay. Plus sine of n times angle in the middle. Okay. All right. So now let's multiply this. And actually, we can go look. You can, to be sure, let's go to 7.11.5 quickly. And so we will just take ourselves to 11.5, peep in the Moivre's theorem, see, and then come back and continue our homework 11.5. So quickly to 11.5, just see an example, and then be able to do the Moivre's theorem, powers of complex number, roots of complex number. Okay, and I'm going to just get to where it is without going through one by one. Okay, and I think there are some parts. Okay, so we just did one, we multiplied. When you are given a power, you multiply, that's what we just said. Multiply the modulus by modulus, all right? So remember we expanded it, but now we multiply modulus by modulus, and then you add angle by angle. This time they are the same angle, but even if they are different angles, you still sum the different angles. You multiply modulus of Z1 times modulus of Z2 and angle of Z1 plus angle of Z2. That's what it says. Okay, the Moivre's theorem, the same thing is about complex numbers, and n is any real number then. Okay, so the Moivre's theorem is that if you are told to expand any number raised to power n in compact form, you can write it as R6 theta to power n, but you don't have to write compact form all the time. All right, so alternatively, you can use what we just did. So 1 plus I root 3 raised to power 8 is equal to, bring down the equation. Now raise R, the modulus, to the power, and then it's just like adding 68 times. So multiply. So we have seen an example, and so we are going to, and when you finish, convert your answer back to rectangular form. All right. But suppose you're given a rectangular form and you are not, you have to make sure you know how to convert rectangular form to real form. So let's go and do that in the homework so we can, in the practice test. So let's go to practice test. So we're going to do exactly what, so we already know how to do this. Already know how to do number one. So let's do number one again, even though we know how to do it. We already know how to do number one. So we are squaring. According to the Moivre's theorem, we square the modulus, and we multiply the angle by the power. Apply the angle by the power. Simplify, sign, then simplify. Okay, and 3 squared is 9. 2 times 30 is 60. Cosine of 60 plus I sine 60. And then if you want to write it in compact form, you write 9 C's 60. Okay. Well, let's do number 2. Following powers. We don't have to get to cycles of, we just need to make sure we know how to convert from standard, from rectangular to standard form, which is polar form. Okay, from standard form to polar form. When you say polar form this time in this section, it means we are talking about trigonometric form. Okay, so we can do number 2, even though it's in radian, the same thing goes. Right here is telling us that R is 1. They didn't give us R. R is 1, so I'm going to rewrite it and make sure that I put 1 there. 1 raised to power 3 cosine of 3 multiply that angle, pi over 3 plus I'm going to use parentheses here, sine, multiply that angle pi over 3. Remember, I got to multiply this angle by 3 also. And finish up. 1 raised to power 3 is 1. I have 3 cancel pi over 3. I got pi there. So that's 180 degrees. Plus, this cancels, so I have I sine pi. So I get my answer after the expansion. And so I can rewrite this as C's pi. C's pi in radian. Okay, if I write 1 here, I can write 1 C's pi. Okay, number 3, quickly, let's do number 3. Whatever you know in this section, make sure you know it very well. If you see it, you know it, you answer. And so that if you see something you don't know, you do not waste time with, especially in exam. In your final exam, in this section is already in exam. But if you see something you don't know it, and don't waste time with it, trust me, you don't need that. If you can do the ones you know and do it very well, you make a good 90. Make a good 90, you made an A. In fact, some of you don't even need A. Some of you don't need A to make an A in final exam. All you need to do good, and so that final exam will take over one of. All right, so let's go back to this question number 3. Question number 3, we have a complex number in trigonometry form or polar form, and the power n is equal to 6. So I want to apply the Moivre's theorem immediately. That's the Moivre's theorem. The power, how to expand this. It is already in polar form, so no problem. It's not a big deal. So I'll just start by 2 raised to power n. That's 2 times 2, 6 times, into big parenthesis cosine of n multiply pi over 3, 6 multiply pi over 3, plus I sine 6 multiply I over 3, pi over 3. And if I divide, I have 2 to the power 6, by the way. I get my calculator and make sure I get it right, because I don't want to do anything in my head. So I'm going to get 2, turn my calculator on, get 2 caret 6. 2 caret 6, and I got 64. So 64 cosine of 2 pi, that's 360 degrees, plus I sine 2 pi. That's it. That's easy. All right, let's do number 4. In number 4, the original question is in rectangular form. So the first thing I have to do is convert, actually, we can actually expand this. We can actually, we have already done something like this. But if it is, let's get one that is in another form. Let's get done something like find the cube root. I'm not doing cube root of that for now. So find the graph of the cube root. First of all, you want to convert that function. Let's convert that function. Convert the function given to us. So we have got z is equal to negative 2 root 2 minus 2 root 2 I. Okay, and the first thing I want to find out is what is the modulus. So modulus is equal to square root of the real part, negative 2 root 2 squared plus negative 2 root 2 squared. Okay, and if I open that parenthesis, I have 2 squared is 4. 4 multiply 2. 2 squared is 4. 4 multiplied 2 is 8. 2 squared is 4. 4 multiplied 2 is 8. 8 plus 8 is 16. Square root of 16 is 4. Therefore, I got R. R is equal to 4. I found the value of R. R is equal to 4. So we got the modulus. So let's get the angle. So I want to use arctan. First of all, you notice that this angle should be, if I draw, I need to draw quickly, draw the, I'm going to put that vector. Let me put the vector up. That angle is negative, negative, so it is somewhere in the third quadrant. So the angle in question is an angle in the third quadrant. So when I find the value of tan theta here, arctan theta, then I should do, I should find the angle in the third quadrant. And that angle in the third quadrant will be angle minus 360 degrees, I mean 180 degrees. Actually, 180 degrees plus 180 degree plus reference angle. Okay, so quickly, tan inverse of the imaginary part of that 2 over imaginary part. Question, somebody has a question? Let me see what your question is. Yes, question? Does anyone have a question? Anyone has a question? Okay, I thought somebody has a question. If you do have a question, you can ask. Okay, if you do have a question, you can ask. All right, so now so the tangent, arctangent is, so what is the angle whose tangent is 1, and that is 45 degrees. If you, I hope you agree. Remember 45, 45, 90. If I'm talking about this angle theta, it is opposite over adjacent. So 1 over 1. And so that is 45 degrees. So the angle is 45 degrees. And since the angle is in the third quadrant, it is 180 plus 45, 225 degrees. Excuse me. So 225 degrees is the angle. So the first angle there is 225 degrees. All right, so I have 225 degrees. So I can write RC is 225 is the first one. R is, or I can say 4. What was the answer? 4 is 225. And then you start adding. So when I grab the first one, then I start the multiples of 90. Start the multiples of 90. We can go back and go to this. Find all complex solutions of this. So we can go back and write x to the power 4 is equal to -5, and we find all the 6 roots. Or maybe we can bring this one back next class. Okay, but the most important thing is to be able to convert an angle to from rectangular, and from rectangular to polar. Okay, and so this is 150. Okay, we're quickly going to, let's quickly go to section 11 point. I know we're not going to scratch it, but let's go to 11.6 and actually start something from there. So 11.6 is the polar coordinate. We're not going to delve into polar coordinate a lot, but I want us to know that in polar coordinates, you already have R also. R is equal to square root of x squared plus y squared, the real part plus imaginary part. So There's something called polar axis, and the polar axis is your R. Okay, and X, you have two. X is the horizontal part, and the point given to you is called r theta. Okay, and when you go over here, there are things you need to know. R squared, the radius is x squared plus y squared. The horizontal part is r cos theta. The vertical part is r sin theta. The same thing with arctangent, the angle. You get the angle. So let's go to homework. I know we're not going to scratch it, but homework 11.6. So homework 11.6 is where we are going. I know we have under 6 minutes, but we might start there when we come next class. So homework 11.6. Homework 11.6. I hope I do have it here. Polar coordinates. Okay. So maybe just we're going to quickly maybe do some graphing and for each point given in polar coordinates, state the quadrant. State the quadrant. Okay, so for this one, this is the quadrant. And by the way, if you are in polar coordinates, there are 5. You have to draw circles. Number 1, this circle has a radius of 1, radius of 2, radius of 3, radius of 4, radius of 5. Forgive my crooked circles. Anyway, now the polar coordinate in A is in second quadrant. And that's the only question. So this angle is in second quadrant. So I'm going to get, so, and I want us to know that in second quadrant, it stops here. This is the point, and the angle is right here. Because the radius is 5, it's in the second quadrant. Anyway, they didn't ask us to find the four other angles. There are going to be 4 other angles next time. B is in the first quadrant. First quadrant. 60 is in the first quadrant. That's a simple question. Now C is in the fourth quadrant. Okay, C is in the fourth quadrant because that angle, and D is in the, is this 4.6? Okay, 213 is in the third quadrant. Okay, so that's about this question. When we come back next Thursday, we start from polar again. We're not going to waste time on polar though. We're going to start from polar again when we come back next. For the rectangular coordinate, 5, -5, plot the point. So before we plot the point, well, we can plot the point, but later on, plot the point, give 2 pairs of polar coordinates for the point 0 degrees to, so they want us to convert this, first of all, convert that angle. So we need to know the R. R squared is equal to A squared plus B squared. And R, I can just find R quickly. R is equal to 5 squared, 25, plus 25, even though it's negative, square root of 50. And square root of 50 is 2 times 25, so 5 root 2. So R is 5 root 2. Okay, and then we want to find the angle. What is tan inverse of -5 over 5? The tan inverse of -5 over 5 is -1. And that angle is in the fourth quadrant. Tangent is negative in the fourth quadrant. So we are looking for an angle in positive direction that stopped here. Okay, so that angle should be, first let's find the angle. Tan inverse of angle 1 is going to be -1. And that is 45 degrees. And 45 degrees as a reference angle in the fourth quadrant is 315, I think. Yeah, it is 315 degrees. Okay, and then we can rewrite it as 5 root 2 sees 315. You can also change it to radian. 315 degrees. Some fractions. So we have already two pairs of polar. Okay, so we wrote only one. We need to write two pairs. Okay, let me draw one pair. First of all, by the way, the angle is approximately 5. So I have 1, 2, 3, 4, 5 poles, and I need to graph two pairs. So the first one is, it's approximately 5. So 5, 3, 15. 5, 3, 15 is here. Remember, it is the fifth pole. So 5, 3, 15. R theta. This is R theta. R equals to 5. So R theta, R 315. Well, guess what? In polar coordinate, when you have an angle, another one can also be an angle. If the angle opposite, I can just find another one opposite. See, 180 degrees opposite. So this angle right there is from here, which means if I add 180 degrees to this one, or you can subtract. So if I subtract 180 degrees, that angle here, and I want you to know that this angle is going to be the same as -5. That angle will be 45. That is 135. It is -5, 135. You can actually be told to list 4 of them. So when I have the angle here in polar coordinate, another angle can be an answer on the opposite side with dotted line. Okay, we're going to stop here and we will quickly finish up. All we need in this section is to be able to graph, convert to polar coordinates. We don't need those flowers. We don't need to be drawing them. And we will have, before then, now we have got to polar coordinates. We will be able to get to circles. We shall be able to get to ellipses, get to parabola and hyperbola, maybe just defining them and be able to draw the graph. And so I'm going to put all of them in the test, because guess what? When you get to calculus, they will not be asking you, did you get there when you were Math 111? They won't ask you that. And it's not about your grade. You can make an A, it doesn't really matter. If you make an A and you don't know the shapes, you don't know how to identify any of these, any of those graphs, it's a problem. So we should be able to identify circle, parabola, ellipsis, hyperbola next class. And then we shall be able to graph more, maybe more of polar coordinates, know how to find, if I'm given one angle, can I find the other 3? If I can do that, then I know I'm good. Any questions?